Okay, hello. This is a different set of notes for independent and dependent variables. So this is going to cover target one, which is identifying independent and dependent variables. It's also going to start to touch on target two, and that's where we're going to write equations to represent the relationship between independent and dependent variables. Okay, so let's dive right in. So the independent variable is the cause. Let me get my pen ready here. It is the cause. In other words, it's something that we control. The dependent variable is the effect. So cause and effect, you guys should learn about that in language arts. So this is something we don't control. The dependent variable is changed by the independent variable. So an equation, that's what we're going to learn about, sort of touch on today, is an equation is a mathematical statement that two things are equal. It consists of two expressions, one on each side of the equal sign. So we can use tables, graphs, and equations to analyze the relationship between the independent and dependent variables. The placement of where the dependent and independent variables go in a graph, table, or equation is always the same. The dependent variable depends on the independent variable. So here we go. Here's our example. So Jane is making pancakes for her family on Saturday morning. She needs 2 cups of mix for every person she is going to serve. So we're going to let S be the number of servings that you need to make, and C is the number of cups of mix you need. So does the cups of mix depend on the servings we need, or does the servings we need depend on the cups of mix? So cups of mix, of pancake mix, depends on these servings we need, or how many people are going to come. So I'm going to say servings you need. So this is the IV, and this is the DV, or dependent variable. So here we go. We need 2 cups of mix for every person. So remember that my IV is always on the x-axis. So number of servings goes here. And then my cups of mix goes on my y. That's hard to do sideways. So we're going to graph the point. We do have a point. We have 2 cups for every person. Okay? So for one person, so number of servings for one serving, we're going to go to the 1, and then we're going to go up 2 because we need 2 cups. Okay? That is known as our unit rate. Unit rate is the measure of 1. Okay, so for one person, I need 2 cups. For 2 people, how many do I need? 2 people means I'm going to need 4 cups. 3 people means I'm going to need 6 cups. 4 people means I'm going to need 8 cups. Okay? Okay, so then if we put that in a table, it's going to look like this. This is where we put our x values and our y values. So x is number of servings. Remember, x is another way of saying independent variable. Number of servings, and y, or our dependent variable, cups of mix. So 1 serving, we need 2 cups of mix. 2 servings, we need 4 cups of mix. 3 servings, we need 6 cups of mix. So the equation from this graph, we would multiply 2 times S, because remember, S is the number of servings you need to make. So 2 times however many people are coming will give us the number of cups. So 2S equals C is our equation. So again, I'm going to put this in another table. So these are the different ways that you can see your independent and dependent variables. So number of servings, and then Y, cups of mix, and you do it the same way. So 1 serving, 2 cups of mix. 2 servings, 4 cups of mix. 3 servings, 6 cups of mix. Okay, so flip over your page, and this is where we're going to kind of start playing with equations. So number 1 says, after school, you and your friends go to the local gas station to buy chips. Let C be the amount of chips you can buy, and M be the amount of money that you can have. So what depends on what? Does the amount of money you have depend on how many chips you can buy? Or does the amount of chips you can buy depend on the money that you have? That's right. It's the amount of chips you can buy depends on the amount of money you have. Amount of money you have. So that's it. So amount of chips you can buy is the dependent variable. The independent variable is the amount of money you have. So a crew of construction workers can lay 20 cones per minute. T is the time that has passed. Remember, time is always the IV, or the independent variable, so we can just do that. That means that C, the number of cones laid, is my dV. So if a crew, they can lay 20 cones per minute, that means I'm going to do, for an equation, I'm going to do 20 T, because T is my IV, equals C, or my dV. So often when you look at our equations, it's going to be whatever the number is times, so whatever times the IV is going to give you your dV. That's what most of our equations are going to look like. So the number, the independent variable multiplied by the number that it gives you is going to give us our dV, okay, or a dependent variable. So here we go. So Manuel saves the same amount of money each month as shown in the table. Determine which statements are true about the amount of money that Manuel saves. M represents the total number of months. We know that months is time, and that makes this the IV. So number of months is the IV, or the independent variable. T represents the total amount saved. Again, money is normally the dV, so dV is money saved. So to find the dV, you just multiply 1 times 15. That gives me, you multiply the independent variable by 15, okay? So 1 times 15 gives me 15. 2 times 15 gives me 30. 3 times 15 gives me 45. 4 times 15 gives me 60, okay? So does the total, let's look at these statements. The total amount saved is 15 times the number of months. That's right, because look, if we do 2 times 15, that gives me 30. 3 times 15, that gives me 45. And same thing here. So the total amount saved is 15 times the number of months. That's true. The equation T equals 15M represents the relationship between the amount saved and the number of months. So if we do M, 15M, so 15 times M, or the number of months, does that give me the T, or the dV, the total saved? Yes, it does. That's true. Does the number of weeks depend on the total amount saved? No, because we are not even measuring in weeks, okay? So let's say a false. That's a false. Sound like a Mario. Okay, so in Elsa's first grade class, they are trying to fill their marble jar. When the class follows directions, the teacher adds 1 marble to the jar. The jar is starting to get too heavy for the students to lift. Okay, so right off the bat, I'm going to label my points. So let me get my highlighter. My first point is at 10:40. So here we go. I'm going to write that. 10, 40. So if 10 marbles are added to the jar, it will weigh 40 grams. Is that right? So we have 10 marbles here. Does it weigh 40 grams? Yep, sure does. And then the weight of the jar depends on the number of marbles in the jar. Is that true? Does how heavy the jar weighs depend on how many marbles are in there? You're darn tootin' it does. So here we go. That's true. Okay, so good luck to you. All you're doing is filling out these notes. We're going to play with it more tomorrow.